So I want you finishing up your bell work. Make sure that that's done for me. Be our guest, put our learning to the test. Relax and find a seat, Cherie, and we'll provide the rest. Welcome to our class, you've won your own free pass to be our guest, be our guest, be our guest. Now you guys go. Good job, just like always.
Alright, so let's go through ceremonies. This is Dalton, this is Ashanti, and I'm David. We're going to start off with our quote.
Okay, the quote is, for beautiful eyes, look for the good in others, for beautiful lips, to only speak the word of kindness, and for poised to walk with the knowledge that you are never alone, by Audrey Hepburn.
We have for our joke.
The joke of the day, what do you call a fruit that goes to space?
What?
A coconut.
In our review, we have been doing target practice for our OCCT.
Okay, thank you. 1, 2, 3.
Very good, guys. So we're going to review what this target practice is, but first thing, I would love for you guys to clean off your desks quietly. If you have anything that's going to distract you, go ahead and move it down. Just want to focus on the targets. If you have your iPads up, that's okay. If you've opened up to where you can see the targets closer. All right. About 5 seconds. Very good. Class.
Yes.
Let's look at the board over here. All right, so let's review what a target practice is and why we are doing this. If we were doing target practice, how many people would be playing this particular game? 4. And can somebody raise your hand and tell me how that you know that? Yes, ma'am?
Because there's 4 rows of the answers.
Because there's 4 rows of answers. So somebody's sitting here, 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 and here. Very good. How many people are playing this game now? 2. And for the same reason, right? We've got 1 row, so somebody must be sitting here. We've got 1 row, so somebody must be sitting here. Why, after you guys make your rows, why do I say teach and you guys say okay? Raise your hand. What is happening? Why do we do this? Aiden.
Because when we say teach, we explain it to each other and teach each other what it means.
Good. I like the phrasing that you used. He said we teach each other. So each of you will have your own row, and do you think they're going to match perfectly? No. They may not. And so this is the time that you're having discussions about what the best answer is as a group. Why do you think we're looking not just for the best answer, but for the other answers and ranking them as well? So whenever we use this target, we go from the best answer down to the worst distractor. Why are we doing this?
Because when we're taking the test, there's always another answer that's really good, but you never know. So if you put it in order, then you can measure and see what other people think. So you're thinking together.
Good. Have you guys ever done that where you took a test and you're like, yeah, that's it? And then you happen to read the other ones and you found one better? Yeah, it happens all the time. So that's why we're learning this strategy for our OCCT, so that we make sure that we totally understand which answer is the best, which answer is the second best, and talk about it within our groups. All right, so after you talk about it, you should have one line like this that all of you have agreed on. If you're having trouble, I'll tell you there's 30 seconds left for rock, paper, scissors, but you've got to have only 1 row. What in the world? Switch, switch. What is that going to mean? Yes, ma'am.
It's when we stop talking to listen to the answers and discuss it with you.
Good. We're switching from you talking to who talking now?
You.
Awesome. All right. With that being said, everybody know what you're doing? All right. On your mark. Get set and go. The question says, through a chemical process, 2 molecules of hydrogen gas react with 1 molecule of oxygen to form 2 molecules of water. The reactant side of the equation has 4 hydrogen and 2 oxygen atoms. How many atoms do you predict will be on the product side of the equation? Do your best. It's been a long time. Do your best. Let's find out what you remember. Good. I like how you're all putting your own answers. So if you have 6 atoms on the left side, how many do you predict will be on the right and why? "30 seconds. Now's the time. All right, and here we go. Teach. Okay. Good job. What's this, Henley? Okay. Perfect. Thank you.
Yeah.
How did we do?
Because
Just kidding. Be wide.
No matter can be created, no matter can be
yeah.
So you remember that. Very good. So C was the lowest? Okay, that's all right. We're going to find out in a minute. Make sure you come down to one line.
Yeah, but
I'm thinking
trouble?
this one is like both A and C on both lines.
Okay. So you guys all agree about B, and you all agree about D. So let's start a line and keep there. And then you may just have to,
Can we add them on the side?
if that's what you think, absolutely.
Do y'all think?
yeah, he's right.
All right, you having trouble lowering them?
We have our 4 lines, but we don't have.
Oh, you just, okay.
Oh, the same, we said.
Yeah, okay, yeah, give me one line. Okay, switch. Uh-oh, switch. Now's the time we're gonna find out. If I have a certain number of atoms on the left side, or the reactant side, is that gonna change on the product side? No. Ooh, and we're going back to what we learned in September. I mean, we haven't talked about this in a long time. Absolutely not. Why?
Because mass isn't created or destroyed.
Mass is not created or destroyed. So what does that make the right answer, class? B. Did anybody disagree and want to give us an opinion of why? Very good. As I walked around, I noticed that most of you absolutely put B as the best answer. What was the worst answer? Absolute. Okay. And that's what I saw. I saw that you all agreed that D was the absolute worst answer. Was A or C better? Was one of them better than the other, or were they equally wrong? Very good. I was so proud of you guys as I walked around. You guys even told me that. You said, they're the same wrong. So when we do that, A, C, A, C. Very good. Tally your points and get ready. On your mark. That means clean off your boards. Get set. And just kidding. I wanted to explain it. Got you guys all excited. Okay. So sometimes when we look at words like oxygen or hydrogen, we forget what we're really talking about. When we say 4 hydrogen atoms, it's actually 2 molecules that look like this. And then we say they combine with an oxygen atom, and that's 2 oxygen atoms in 1 molecule. And all they do, I don't know if you guys remember this from a long time ago, but they just switch partners. They just rearrange themselves. If you look, there's 4 on the left. There's still 4. That'll never change. There's 2 on the left. There's still 2 on the right. That'll never change.
That's great.
Do you get it?
Yeah.
I told a chemistry joke. There was no reaction. All right, on your mark.
That's great.
Get set and go. A student mixes 2 grams of baking soda, 10 grams of vinegar in a container that has a mass of 50 grams. The student observes bubbling. How much mass would the container system have after the reaction? I'll give you guys a minute to write down your answers. Right, what you think? Okay, some of you just need about 10 more seconds. I'm going to bang on your table, don't be scared. Teach. Okay.
Because it says measure greater and measure less, but they like whenever you add it up, it's still like the same thing. So they're both like equal. And then